Okay, so now let's calculate the path difference between S1 to P and S2 to P. So here I draw the diagram again and just want to show you, in reality, the distance between the slit to the screen is pretty large, that it usually measure in meter. It can be like 1 meters or more than that, like 2 meters, but the slit width of the slit is very small. It's just in range of millimeter, so you can see that it's like a ratio of 1,000 times difference, right? I cannot draw that scale on the paper scale, on the outscreen scale, ratio, but I just want to emphasize here that imagine you can see the difference between millimeter and meter, right? So that's why, in fact, we can see that S1P and S2P, these two paths, is kind of parallel to each other, And because they are kind of parallel to each other, there will be some similarity in the angle. So what is the angle we want to talk about here? Let's just have a look at the below diagram. So here again, our purpose is to calculate the path difference, right? So that should be S1P minus S2P, because in this case we can see that S1P is slightly longer, right? And as we have emphasized here, you can imagine like S2P kind of parallel to S1P. So if we want to find this one here, I will try to have another point S2 prime on S1P, so then we can have S2P equals to S2 prime P. Make sense, right? So then you can see that we have a isosceles triangle, right? And then we will have that PH here is the height of that triangle, right? But the thing is that because these S2P and S1P kind of parallel to each other, so that's why you can see that this angle here, S2 prime P, this angle here, is very similar to this angle here. It almost like right angle as well. It's like 89,999 right degree, So that's why you can consider this triangle S2, S2 prime, S1 is a right triangle. It's just because of this property. So if we got this one as a right triangle, let me just draw them here again. So then you can see that S1, S2, it just turns out to be the hypotenuse, right? And then can you see this red angle here? And again, because these two lines S2P and S1P almost parallel to each other, you can see that this angle is just equals to this angle, And actually this is the angle theta. Between what? Between the line that from the middle point, okay? S2 is the middle point of the slit. Do you remember that from the previous figure, right? Here, see that? It's the middle point of the slit. So then you can see that from S2 and S1, it should say half of the slit, D over 2. From the middle point of the slit, you draw a perpendicular line to the screen. So then this one will be the distance between the slit and the screen, which usually measure in meter, And then the angle, theta, is defined between that point P of inches and from the middle point to that point. See, this is how the angle theta is defined. And then you see, because of this property, this angle here is kind of equals to that angle. Make sense, right? You can see that why, because this red angle here plus with the blue angle here equals to 90 degrees, right? And actually this angle here, because we consider this one is a right angle, then you can see that its angle also like equals to this angle, because the string here and the slit here parallel to each other, right? So when you have the two angle here at this position equal to each other, then you got this red angle here equal to each other as well. So basically this is the theta, right? And this is the theta, you see? Now in our triangle S1, S2, S2 prime, we have a hypotenuse S2, S1, and we have this angle theta. And then we can also see that the path difference, this is the path difference, S1, S2 prime equals to what? This is like one side of the right triangle, right? It should equal to the hypotenuse times with side of the angle opposite to it, right? Yeah. So now, this one turned out to be D over 2. And then you can see that if this one is a dark fringe, then the path difference should equal to n lambda divided by 2, right? An integer number of half of the wavelength. So then now we see the expression. Let me write them here, okay? D over 2 times sine theta equals to n lambda over 2. So you see 2 on both sides, we can cancel out them. And finally, we got this one. And this is what we want to prove from the beginning. We want to derive this one from the beginning. Is it good? Okay, let me know if you have any question, please. Thank you.